write some code using these colliders. So let's get rid of our start and update method. So we have a few different Unity methods that can be used with colliders. So we can go on collision enter. Now each of these methods also have a 2D version, capital D, but we won't be using them for this because we're making a 3D game currently. So we have on collision enter, we have on collision exit, and we have on collision stay. So this one, on collision enter, gets called when something collides with it. It's called once when something collides. On collision exit, gets called once when it leaves. So these both work very similarly, except this is on the entry to the object and this is on the exit. Now this one gets called at the same rate as fixed update while the object is still colliding. So we get called at physics rate So for default, that'd be 60 times per second, or whatever, but it could be whatever you've set your physics rate to be in your game. So this will get called while the object is still touching the other object. Now, there's also all these methods in trigger version, which work exactly the same, except with a trigger collider instead of a collision. Now, I almost would never use on collision stay, but on trigger stay, I would use all the time. Why doesn't it like that? Because for on trigger stay, what I'd be doing is I'd be detecting while an object stayed in a zone and then running code based on what is happening while it's run in that zone. Now let's write some code using these collision functions. So let's just get rid of the other two for now because we don't need them. We're just going to use on collision enter for this one. So we'll start with this passes a variable into the. So when you write a method, you can pass a variable in. So when this is called, it's giving us information about the collision object. So let's use collision dot game object dot transform dot position to access the position of the object that collides with, and let's set it to equal to new vector 3, and then we're going to use, let's copy this because we're going to use it multiple times. Go Control C. We're going to set it to a new vector 3 of the same position on the X, which is the left and right. We're going to send it to the Y plus 5. That's its up and down. And then we're going to set it to the same on its Z, which is its forward and backwards. So in Unity, Y is your up and down. I know in some other softwares, it is your left and right, and X is your up and down, and then Z in some. But in Unity, X is your left to right, Z is your forward and backwards, and Y is your up and down. So now what this code is doing is it's grabbing the game object that has collided with it. It's grabbing its position, and then it's setting its position to a new vector 3. A vector 3 is an XYZ coordinate, which is the same position on the X as what it currently is, the same position on the Z as what it currently is, and then it's using its current Y position and adding 5 to it. Now you would think you could just do something like this. But you cannot access the Y directly like this. You have to change the whole transform dot position And the way we do that is by accessing all of them individual values inside a new vector free and changing them all, even though we're setting them to the same when we change them. All right, so let's go back into Unity. And now if we, so let's just take a sec to reload. We attach this script to our cube, and then let's make our cube a little bit bigger. Let's set him to be 2 by 2 by 2. Let's put him underneath the player. And let's move the player up a little bit further. So now, if we click play, when the player hits, he gets shot back up to 5 and he's going to keep looping. So that's an example of something you can use. It's a reaction that happens each time a collision is made, and you'll use this sort of interaction, probably not to do exactly this, but to do lots of functionality throughout your game. This is probably one of the more common ones you will use. See you in the next video.